Assalamualaikum warahmatullahi wabarakatuh, and good morning, madam. So, right now, our group will present about the apply maximum and minimum problems. Before we gonna start about the present, I would like to intro our group's members. So, the first member is me, as Muhammad Islam Munjir bin Abdul Rashid, 2021 83 2018. So the first one is about the introduction of the apply maximum and minimum. Application of maximum and minimum is we set dA over ds equals 0 to find this value. Determine a constant such as the cost of a fence. Choose a variable to maximize or decrease such as an area A. Using the formula A equal F S Y, express the variable in the order relevant variables. Next, the process of finding maximum or minimum value is called optimization. We are trying to do things like maximize the profit in a company or minimize the cost or find the least amount of material to make a particular object. Next, we're gonna try to do a question from the apply maximum and minimum. So, as we can see here, we have the square and the half sphere. So, the question said, a rectangular door with a semi-circular top as shown in figure is to have a perimeter of 6 meters. So the first A is express Y in terms of S. The B show the area of the door is given by A equals 24S minus 4S2 minus theta x2 over 8. C. Determine the maximum area of the door.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dinar Ashraf bin Masyudi, and my session I will teach you about the first question. Okay, we start with the first question. Express y in the term of x. For the solution is we need to know the exactly total perimeter for the diagram. So the perimeter for the area is 6 meter. So if we look to the diagram, we have one square and half hemisphere. So for the formula for the square is x plus y, and for the hemisphere is 2 pi r over 2 equal to 6, which is 6 is the total perimeter. So why we use 2 pi r over 2 is because the hemisphere formula is 2 pi r over 2. So the next step is we combine the y become 1, so it will be 2y plus x, and we terminate 2, so that the equation will be pi r over 2. For the hemisphere formula, we will terminate 2 and 2 over 2, and it will be pi r. So for the r, actually is a radius. So r is 10 for radius, so it will be s over 2, and pi will be the outside. So the new equation, it will be s plus 2y plus pi s over 2 and equal to 6. So we want to so back to the question. The question want us to express y in the term of s. So 2y equal to 6 minus x minus 5s over 2. So here it will be 2y equal to 12 over 2 minus 2s over 2 and minus 5s over 2. So we just want y just stay, and what we do is divide all the equation by 2. So it will be 12 minus 2x minus pi x over 2. And it will be y equal to 12 minus 2x minus pi x over 4.
I will continue for the B on how to get the equation given. So first we can use the formula A equal to xy plus r plus pi r square over 2. X we put insert. We don't know yet about the x, and we already get the y from the question above before. Then for the radius is x over 2 because hemisphere it's half, and we calculate. Then the x we expand and become 12x and minus 2x squared minus pi x squared over 4, and same as the side, pi x squared over 4 over 2. Then the 4 over 2, the 2 multiply with 4 and become pi x squared over 8. After that 4 and the left hand side need 2 times with 2 to make the denominator 8, and same, and it become 24x over 4x squared minus pi x squared over 4 over 8, sorry, plus pi x squared over 8, and the answer will become 24x minus 4x squared minus pi x over 8, which is the same as the given in the question.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firzal Husna, and I will explain to you question C. So based on this question, we will ask to determine the maximum area of the door. So the equation for the area is 3x minus 1 over 2 squared minus 1 over 8 pi squared. First step is we use the first derivative test, which is dA over dx equals to 3 minus x minus 1 over 4 pi x. Let dA over dx equals to 0. So 3 minus x minus 1 over 4 pi x equals to 0. We bring everything to the right side and leave 3 by itself. And we calculate it and we get x equals to 1.68 meters. The next step is by using the second derivative test, which is dA over dx equals to 3 minus x minus 1 over 4 pi x. While the second derivative test is d squared a over dx squared equals to 0 minus 1 minus 1 over 4 pi. Since the equation is less than 0, so the x equals to 1.68 meters is the maximum value.
So for the step 3 is second derivative test. D square a over dx square equals to 0 minus 1 over 4 pi equals negative 1 minus 1 over 4 pi equals 0. So we can get the x is 1.68 meters in a maximum value. For the question C, we can see here is a maximum. 24 multiply 1.68 minus 4 multiply 1.68 square minus pi multiply 1.68 square over 8. So we can see here the answer is 2.52 meter square.